Ladies and gentlemen, my name is Komsak Alamala, a master degree in material science and nanotechnology program, Faculty of Science at Conductive University. I am very excited to be here today. This is actually my first ever talk in an international conference, so thank the organizer for giving me opportunity to present my work at this meeting. The topic of my talk today is effect of conductive agent, electrochemical performance of water-based lithium-nickel manganese cobalt oxide cathode electrode for cylindrical cell production of lithium-ion battery. About the outlines, at first I will talk about the NMC battery application and water-based. And the second is problem statement and the object, and the material that I use in this experiment and the processing. The last one is methodology and the result. Uh, the first one is application of NMC battery, making NMC the most successful lithium system and suitable for EV powertrain. These batteries are currently in high demand given the high specific energy and excellent thermal characteristics. As mentioned above, NMC has been used by many EV manufacturers. Lithium nickel manganese cobalt oxide. Making NMC an electrode can be designed for high specific energy or power with high density. The secret of NMC is combining nickel and manganese. Nickel is known for its high specific energy but poor stability. Manganese has the benefit of forming a spinel structure to achieve low internal resistance but offer a low specific energy. Researchers are using nickel-rich electrodes to increase energy density, while reduction in cobalt is also helpful since its lower cost. Uh, the next slide is about the process to making the battery, slurry preparation, coating and dyeing, calendering and casting electrode, cell assembly and electrolyte filling formation. But this experiment we will focus on the slurry preparation. uh, Problem statement of this experiment: NMP-based batteries are toxic to the environment and expensive. Batteries that use water as a solvent are difficult to make the slurry homogeneous. An active material can react with water, carbon dioxide, and oxygen, resulting in low electrochemical performance. The site of conductive agent uh, is significant battery performance, and the object to make the battery lithium nickel manganese cobalt oxide with water base, and to compare electrochemical performance and catchability of battery with different conductive agent, the content conductive agent, and the time mixing. Lithium battery with water-based battery. The lithium-ion battery have been widely used in numerous portable electronic devices, including laptop computer, mobile phone, and the last scale is applications such as electric vehicle. However, lithium receive its limits, leading to the high cost of NMP-based that use PVDF as binder. So the battery that use water-based as solvent is promising candidate due to its cost saving, environment friendly, energy saving, and noise recovery. Uh, The next slide is about the conductive agent and binder that we use in this experiment. For conductive agent, we use acetylene bag. It's lighter than KSC and high electrical conductivity and high packing density. And the KSC is the most stable form of carbon and heat resistant, corrosion resistant. About the binder, in this experiment we used CMC natural cellulose, has received more attention in recent time due to its much easier dissolution in water and lower cost compared to PDF binder. Using CMCS binding has better high capability than the one with PDF as binder. And SBR as the elastomer used in almost 17% of batteries show strong binding force, high flexibility, and good heat resistance. Conductive agent that provide electron transfer between the active material and the current character. So in this experiment, we will control the ratio of material at first time 2 hour, and the second table is time 3 hour. This table is NMP based. And it's not just only time that we control, we also control the content of conductive agent at 7% and 5%, and the type of conductive agent, acetylene bag and the KS6. About the methodology, cathode electrode preparation and testing, we will focus on the NMC and conductive agent that make 2 or 3 hours that we control, and after that we will assemble the cylindrical cell and testing battery at specific capacity, efficiency, and cycling stability. Uh, this is the result of castability of cathode electrodes. Time mixing 2 hours the surface is rough, but 3 hours the surface is smooth. Because of when the mixing time is not enough to make the slurry become homogeneous when coated on aluminum foil, resulting in rough surface. And AB as conductive agent is smoother than KSC because of the particle size of acetylene bag is smaller than KSC, resulting in significantly smoother. The result of electrochemical performance of lithium-ion battery cell. The maximum specific capacity and efficiency is 104 mA per gram, and the efficiency is 64% with the formula that we used, KS6 7%, and the time mixing is 2 hours. Battery with a ratio of 7% conductive agent better than 5%, and the KS6 had the highest electrochemical performance in both ratio of conductive agent. And compare 3 hour, the time mixing 3 hour, the maximum specific capacity is 130 mA per gram, and the efficiency is 65% with the formula that use KS6 7%, and the time mixing is 3 hours. And the NMP base, that specific capacity is 137 mA per gram, and the efficiency is 82%. Why the time mixing 3 hours is the specific capacity is better than 2 hours? Because of the 3 hours the conductive agent and active material are more distributed and less accumulate with its dispersion as shown in figure A, and the time mixing 2 hours conductive agent and active material are accumulated as shown in figure B. As a result, electron and lithium-ion are difficult to pass. The last slide is about the cycling stability of lithium-ion battery. It is not possible to conclude with formula has the best cycling stability, but for 4 cycle the best one is B73 at 83%. To conclusion, NMC with water-based cat on to both sides of aluminum foil. The difference is surface of mixing time 3 hours, surface is smoother, with 2 hours the surface is roughness, and KC conductive agent, the electrical performance better than AB conductive agent, both ratio of 5 and 7%. Water-based, the electrochemical performance is an acceptable level, which is similar NMP-based. The specific capacity is 115 mA per gram, and the efficiency is 65%. Those experiments were done to determine if water-based battery can be produced, and further developed by determining the parameter that must be controlled to provide battery performing battery. That's being the presentation to the end. Thank you for your attention.